Good day everyone. This is Hannah Estrada from BS Applied Math 4A. Today, I will be presenting to you my mathematical modeling project entitled Optimizing Content Production Using Simplex Method, the case of Mr. Regaspi. This study uses linear programming to help a content creator maximize his weekly income while considering his limited working hours. And now, let's proceed to the problem. Mr. Gaspi, a content creator, regularly produces educational and entertainment content each week. He allocates 40 hours weekly for filming videos and 60 hours for editing, and he does not want to exceed these time limits. For each educational video, Mr. Regaspi spends 10 hours filming and 20 hours editing. For each entertainment video, he spends 10 hours filming and 12 hours editing. He earns 20,000 pesos per educational video and 10,000 pesos per entertainment video. How many videos of each type should Mr. Regaspi produce each week to maximize his income? To solve this, we use linear programming and the simplex method. And here are the decision variables. Let x sub 1 be the number of educational videos per week, x sub 2 be the number of entertainment videos per week, and z be the profit. So now here's the LP model. We want to maximize z, which is equal to 20,000 x sub 1 plus 10,000 x sub 2. We have here the constraints. Filming constraints, which is the 10x sub 1 plus 10x sub 2 is less than or equal to 40. Editing constraint is 20x sub 1 plus 12x sub 2 is less than or equal to 60. The minimum required videos, which is x sub 1 plus x sub 2 is greater than or equal to 4. And the specific content mix requirement is 2 so x sub 1 plus 3 sub x sub 2 is equal to 12. And we have here the non-negativity. X sub 1 x sub 2 is greater than or equal to 0. So now, let us convert inequalities to equalities using slot and artificial variables because we will solve using the Big M method. Constraints become, first is filming. Filming became 10x sub 1 plus 10x sub 2 plus s sub 1 is equal to 40. Editing is 20x sub 1 plus 12x sub 2 plus s sub 2 is equal to 60. Minimum videos is x sub 1 plus x sub 2 minus s sub 3 plus a sub 1 is equal to 4. The linear condition is 2x sub 1 plus 3x sub 2 plus a sub 2 is equal to 12. And the objective function becomes z is equal to 20,000 x sub 1 plus 10,000 x sub 2 plus 0 s sub 1 plus 0 s sub 2 plus 0 s sub 3 minus ma sub 1 minus ma sub 2. This discourages artificial variables from entering the final basis. Let us construct an initial tableau. So this tableau contains all variables x sub 1, x sub 2, s sub 1, s sub 2, s sub 3, and we add the artificial variables, which is the a sub 1 and a sub 2, and also the objective function row. Then we compute the c sub j row, wherein we will multiply the c sub b to x sub 1 column, x sub 2, s sub 1, and so on. And the next step is we compute the c sub j to c sub j. So the most positive value tells us which variable will most improve the objective function. So in this tableau, the pivot column is x sub 2 because it has the highest positive value in c sub j minus c sub j. Next is we compute the ratio by dividing b to x sub 2 column, and we'll choose the smallest for the pivot row. Since there are three smallest value, we will choose a sub 1 row to eliminate or remove the artificial variable and replace it by x sub 2 to its basis variable. Thus, 1 is the pivot element. Next is we will make all other entries in the pivot column become 0 by solving the following. Let r sub 1 u is equal to negative 10 r sub 3 plus r sub 1. and let r sub 2 new is equal to negative 12 times r sub 3 plus r sub 2, and let r sub 4 new is equal to negative 3 r sub 3 plus r sub 4. And the result is in tableau number 2. So next, we again compute c sub j minus d sub j. We check if there is still a positive value. So there is. So another pivot is needed. So as we can see, the highest positive value is in the S sub 3 column. Thus, S sub 3 is a new pivot column. Then let's identify the new pivot row by choosing the smallest positive ratio, and it is in the A sub 2 row. Then next, let's perform row operations again by letting R sub 1 new be equal to 10 times R sub 4 new plus R sub 1 old. R sub 2 new be equal to negative 12 times R sub 4 new plus R sub 2 old. R sub 3 new be equal to 1 times R sub 4 new plus R sub 3 old. And lastly, R sub 4 new be equal to R sub 4 old over 3. Thus, the pivot becomes 1 and all other entries in the pivot column become 0, thus forming tableau number 4. We again check c sub j minus c sub j. So this time, there are no more positive values. That means we have reached the optimal solution and no further improvement is possible. So we proceed to interpret the tableau. From this tableau, x sub 1 is equal to 0, x sub 2 is equal to 4, and s sub 1 is equal to 0, s sub 2 is equal to 12, and s sub 3 is equal to 0. This means 0 educational videos, 4 entertainment videos. Now, compute the total income. Z is equal to 20,000 times 0 plus 10,000 times 4 is equal to 40,000. Or we can also check if it satisfies the original equalities. So in filming, 10 times 0 plus 10 times 4 is equal to 40. Check. Editing, 20 times 0 plus 12 times 4 is equal to 48, which is less than 260. Check. Minimum total, 0 plus 4 is equal to 4. Check. And lastly, the package, 2 times 0 plus 3 times 4 is equal to 12. Check. Hello. To conclude, Mr. Legaspi should produce 0 educational video and 4 entertainment video to maximize his weekly income. So, that's all. Once again, this is Hannah Estrada, and I hope you guys have gained new knowledge from what we talk about. So, thank you for watching and God bless.